1. This is RTP. This is RTP180.
So it's going to be fun following Steven because I don't have any cool props and I'm definitely not doing a striptease. So I'm here to talk about what is the university's role, right, in military technology. And I think you'll be really surprised at all that happens right here in the Triangle. So I'm with the UNC System office, as Wade said, and for those not familiar, the UNC System is comprised of the 16 public universities across the state of North Carolina, and we have several of them right here in the Triangle. So we have NC State, we have North Carolina Central University in Durham, and then we have UNC Chapel Hill. So Duke University is not part of the UNC System, but we do partner with them quite often, so we'll be talking about them just a little bit too. But there is a significant amount of research that applies to the military that we do in partnership with the military, and it's mutually beneficial, so that's what I'm going to talk about today. So I thought that Stephen might mention the Army Futures Command. This is basically the Army's modernization efforts. And so Army Futures Command, right, they're going to be responsible for the research and the development and the innovation across the entire Army for the future. And they looked at 150 cities across the entire country to figure out where to put the headquarters for this command. They narrowed that down to 5. The Triangle was one of those 5. So ultimately it landed in Austin, Texas, at a building called the Capitol Factory, which is a lot like this building, the Frontier, that we're in right now. But we're sorry that it didn't come here, but I think we learned a lot from that process, and it really shined the light on all the innovation that is here. And I'm just going to touch on just a tiny piece of what happens at our universities here. So if you look at Chapel Hill, Duke, and NC State, 3 Tier 1 universities, over $2.5 billion of research every year that is externally sponsored. If you add in North Carolina Central University and RTI International, it jumps to over $3.5 billion a year. That's a lot. And a lot of that is relevant to the military. At Duke alone, almost $60 million in 1 year was sponsored by the Department of Defense directly. And that doesn't account all the indirect stuff. At NC State, they are the #1 university in the country for Army funding from a program called STTR, which is Small Business Technology Transfer. So that means that NC State does a great job at partnering with small companies to transition technology to the warfighter. So that's really exciting. So I think a lot of it comes down to, the basic research, the applied research at our universities. A lot of the time has some sort of national security or military implication, but it's not immediately obvious. And it's often about translation and understanding the lingo. So the military has its own lingo, academia has its own lingo, and so it's connecting those dots and helping people understand each other. And that's the fun part of my job that I get to do, is go around to our 16 universities and meet with some of our 225,000 students and meet with some of our 45,000 faculty and staff, understand what research they're doing, and then help translate it to the military partners that we have to connect those two. So when the Army Futures Command stood up, they came up with 6 modernization priorities. One of them is soldier lethality. So when you think of soldier lethality, probably conjures up certain images, right? Like big, strong, muscular dudes kicking down doors. But that's not all it is. Soldier lethality is about a lot more than that. It's about protecting the soldier. It's about preparing them and training them to be effective and to get their job done optimally. So what we learned from this process is soldier lethality includes things like protective gear. So in the picture on the left, this is research at NC State in the Mechanical and Aerospace Engineering Department, where they are developing a composite metal foam that can absorb a bullet multiple times and protect a soldier. So this would be game-changing for body armor. The picture in the middle is a testing chamber, also at NC State in the College of Textiles. So this is where they can test chemical warfare agents, simulants, to see if the uniforms can protect against fires and other threats. On the top right, we have Chapel Hill School of Medicine. Some folks there in infectious diseases are working on malaria vaccines and other ways to protect soldiers against infectious diseases in places where they're deployed. In the bottom left, at North Carolina Central, there's a place called BRIGHT, which is a biomedical research institute. They're doing a lot of cancer research there funded by DoD. They're working on carbon nanotubes that can inactivate bacteria that causes anthrax, among other projects. The bottom right picture is at NC State. They have, in the Hunt Library, for those of you who've never been, it's on Centennial campus, beautiful, gorgeous building. On the top floor is a gaming and simulation lab. And this is a picture of a naval ROTC simulation exercise. That is such a cool building, and I recommend going to visit it if you ever get the chance. And there's so much more. These are just a couple of examples. Also at UNC Chapel Hill, there's a professor there named Dr. Mike Ramsey, who has worked on developing basically miniaturized mass spectrometry for chemical and biological detection, and has gotten funding from the Army. Probably Dr. Lee was involved at many points along that process. There's a spin-out company that's now based in Boston doing some of that work. So this map just really shows you that the yellow dots are the 16 campuses of our university system, and the blue dots are the presence where we have military installations and commands. So we decided to basically build a partnership and multiple partnerships with some of these commands. And we have a whole range of activities that span research and technology, as well as degree programs where our universities have custom designed degree programs for service members. We have internship and fellowship programs. So I manage an internship program where we've had about 55 students go to Special Operations Forces commands, and they spend the summer. Some of them have gotten full-time jobs afterwards. Some of them have gone on to do really exciting careers, including working for the Redskins and the Oakland Raiders. I better hurry up here. So why do we do this? It's mutually beneficial. We get to get technology in the hands of warfighters. Our students and our faculty also get to get the hands-on experience. They get to apply their intellectual capacity to real problems. Everybody benefits. And now I'm going to give you some tangible examples. This will take me like 30 seconds to wrap up here. But if you look at this kit that a soldier, like a communication soldier, has to wear. They have to carry around a ton of antennas based on the mission set that they need. So what if that could be replaced with something like this? There's research at NC State, and Dr. Michael Dickey and his colleague Jake Adams, they are developing something that uses a liquid metal alloy that you can apply. You can manipulate the properties of that alloy either through applying electrical voltage or mechanically stretching it, and you can dynamically tune the frequency of the antenna. So there's a lot of game-changing applications to that research, which is being developed now. We also have a lot of engagement with our students. So we have had probably a couple dozen student engineering design projects over the years. A lot of that came through Dr. Lee's support. And we've had some battlefield medical gear developed. We've had UAV and drone technology, non-lethal technologies like the cylinder you see here is basically like a smoke bomb that you would throw in a room and it would distract and disorient the adversary in a non-lethal manner. Smartphone apps for cybersecurity operations, and just a whole host of, actually the picture on the bottom middle here is for canine handlers, for dog trainers to protect them against the dogs. And it realistically mimics skin, bone, and muscle. And so that was a project that came out of working with the working dog folks. And the last thing I'll say is we've had a number of student design competitions, and one was on 3D printing. So we had students from UNC System, from the community college system, and they teamed up with operators from Special Forces, and they came up with different design concepts that could be 3D printed in the field. The team that won came up with an aerial supply device that would be dropped from a helicopter, and it's a hollow lattice kind of structure, and it would basically deliver something like blood or ammunition or batteries and drop it onto the battlefield and protect the contents in a heated battle situation. So there's a lot more I could say, but I'll stop there and try to answer any questions that you might have.